Dear students, in the last video we talked about what is dihedral angle, what is the meaning of torsional strain, angle strain and static strain and how they differ from each other. So in today's video we are going to talk about the conformational analysis of ethane molecule. Shown in the picture on the left hand side is the eclipsed conformation of ethane, and on the right hand side it is the staggered one. In the staggered conformation, dihedral angle is 60 degrees, while in eclipsed it is 0 degrees, right? So conformational analysis, so these are the Newman projections of ethane molecule in the staggered conformation and in the eclipsed conformation, right? So what we are doing here is we are rotating this by 60 degrees and this keeping the red one fixed and moving the blue one, right? So this comes here, this goes here and this goes there, and we get the eclipsed one. The energy of the eclipsed conformation is higher than the staggered one. Why? Because in eclipsed conformation there are hydrogens which are quite close to each other, so their electron clouds, they start repelling each other because of the similarity of charge, right? So energy of eclipsed conformation is higher. So we are going to plot them as the energy diagram. On the vertical axis we have the potential energy, so you can take it as energy, and on the horizontal axis we have the dihedral angle. When dihedral angle is 0 degrees, the conformation is the eclipsed one, where the energy is higher because of the torsional strain. And then when you move this by 60 degrees, this hydrogen comes here, which you can see. This hydrogen goes here, which you can see here. This hydrogen goes there, this one. So here the things are as far apart as possible. So this is very much stable. This is the staggered conformation. Now you rotate it by another 60 degree. That is a total of 120. This hydrogen comes here. This hydrogen comes here. This hydrogen comes here. So you again get an eclipsed conformation and so on. So you're repeatedly getting eclipsed, staggered, etc. Right? All the eclipsed conformations, they are of the same energy. So whether it is at 0 degree or 120 or 240, all of them, they are of same energy. So they all are degenerate in terms of energy. All staggered conformations are also degenerate. The energy difference between staggered conformation and eclipsed conformation is 12 kilojoules per mole, which means that eclipsed conformation has more energy. How much more? 12 kilojoules per mole more than this one, staggered one, right? Now we have to find out why what accounts for this 12 kilojoules per mole. Shown is the eclipsed conformation, and we know that the energy increases because of these interactions between hydrogen and hydrogen, and we know that the total energy has increased by 12 kilojoules per mole. So since we have 3 hydrogen-hydrogen eclipsing interactions and total energy which has increased because of this is 12 kilojoules. So we have 3 hydrogen-hydrogen eclipsing conformations. So total energy, so each hydrogen-hydrogen eclipsing interaction accounted for 4 kilojoules per mole of energy. So every hydrogen-hydrogen eclipsing interaction accounts for increase of 4 kilojoules per mole of energy, right? At any given time, the staggered conformation is changing to the eclipsed one. So this change from eclipsed to staggered to from staggered to eclipsed, this is happening like millions of times per second. Like in 1 second, they're changing millions of times. And if you have, like, say, you take a sample of 100 molecules of ethane, right? You take a sample containing 100 molecules of ethane at a given temperature, then 99 of those ethane molecules would be in the staggered conformation at that time, and only one can be found in the eclipsed one. Why? Because staggered conformation is of low energy and thus high stability, and molecules are more comfortable in the low energy state, or in the highly stable state is the one which is low energy one. So I repeat, at any given time in a sample, 99% of the ethane molecules, they prefer to stay in the staggered conformation rather than the eclipsed one. Now we know that it's because of the torsional energy and all that. But what is the basis of that torsional energy? What is the basis of that hydrogen-hydrogen eclipsing interactions torsional energy? So the best explanation to date is the one which is coming from the quantum mechanical calculations. So when the ethane molecule adopts staggered conformation, in that case, the bonding molecular orbital of a CH sigma bond and the anti-bonding sigma star molecular orbital of the another CH bond, they are parallel to each other. And since they are parallel, so a good overlap is possible between them, and because of which the energy of the system decreases and the stability of the system increases. While in case of eclipsed conformation, such a planarity, like they are not planar when you have the eclipsed one. So no overlap is possible, or very less overlap is possible. So the energy of the system does not decrease to that extent. So stabilizing interactions between the carbon-hydrogen sigma molecular orbital and carbon-hydrogen sigma star antibonding molecular orbital, they are responsible for more stability of the staggered conformation. This finishes the conformational analysis of ethane. So if you're not sure about what's the meaning of dihedral angle or the torsional strain or angle strain or steric strain, I would attach the link for the YouTube video which I have uploaded before this video. So kindly go through that. Now we'll do the conformational analysis of propane. So propane is CH3, CH2, CH3. There are two carbon-carbon bonds. We can choose any one of them to draw the Newman projection and do the conformational analysis. So I have chosen this bond. And if I focus on the carbon which I have highlighted in blue, then that carbon is connected to 3 hydrogens. So you can see that the back carbon is attached to 3 hydrogens, which I have already given the blue color. The one which is the front carbon is attached to 2 hydrogens, which I have shown here, and 1 methyl group, which I have shown here. And I have placed them as far apart as possible in this structure. You can start from anywhere, but I preferred when they are as far apart from each other as possible, because that is the state of lowest energy, because there would be no interactions whether they're steric or torsional, right? So this conformation, which I have labeled as A, this is the staggered conformation. The things are as far apart as possible. So this is of lower energy. Now if I rotate this structure by 60 degrees, keeping the red things or the front carbon fixed while moving the back carbon, so this hydrogen will come here. So you can see it is coming here. This hydrogen will go here. So it's going here. This hydrogen will go here. So it's here. So this is the eclipsed conformation, although it's not fully eclipsed, but that's how the molecule is. So things are eclipsing each other. Now if I rotate this further by 60 degrees, this hydrogen will come here, this hydrogen will come here, and this hydrogen will come here, which we can see. Now if you compare the last structure or the C structure with A, they are the same. So it means in propane also we have two extreme conformations. One is staggered, other is eclipsed. And the staggered one is stable than the eclipsed one by 14 kilojoules per mole. Or we can say that the energy of the eclipsed conformation is 14 kilojoules per mole. Now, this is the eclipsed conformation. And we already know that because of the hydrogen-hydrogen eclipsing interactions, the energy of the system increases by 4 kilojoules per mole. And experimentally, we have found that the energy of the system has increased by 14 kilojoules per mole, of which hydrogen-hydrogen eclipsing accounts for 8 kilojoules per mole. It means the energy which has increased because of methyl and hydrogen eclipsing strain, that would be 14 minus 8, which is 6 kilojoules per mole. It means that this interaction is responsible for increase of 6 kilojoules per mole of energy. So hydrogen eclipsing is responsible for increase of 4 kilojoule, another hydrogen 4 kilojoule, and the one with methyl and hydrogen, that interaction accounts for 6 kilojoules per mole, since methyl is a bulky group as compared to the hydrogen atom. So this finishes the conformational analysis of ethane and propane. If you like the content, please do like and subscribe and leave your comments. That would kind of catalyze the whole process of uploading new and newer videos. Thank you very much.